Hello, my name is Luke Friedrichs, and for my project I did graph of y equals tangent x. Now, for the first number for any graph, I like to do 0 because it's the easiest number to work with. Let me choose 0, and then the corresponding pair to that is 1, 0. Now, finding the y of the graph tan x is just y equals y over x. So that would be 0 divided by 1, which, in this case, equals, in all cases, equals 0. Now for the next pair, we move on to pi over 4, which gives us this pair, which is the square root of 2 over 2 divided by the square root of 2 over 2, which equals 1 because they are both the same number. Now if we go down to the negative pi over 4, they would both be the same number, but one of them is negative, so that would make it a negative 1. Now if we go on to the pi over 2, we see that the pair is 0, 1, which in tan would be 1 divided by 0, which we can't do, right? So that would be undefined, which means that the graph can never touch that line. There's a dotted line on that, and it can never touch it. Same with here. It is stuck between two lines, and we'll see that when we try to graph it down here below. So when you go to graph it, you put 0, 0. Then you put negative pi over 4, negative 1, and then you pi over 4, 1. And then it's undefined on those two because you can see it never touches there. It'll go on forever and ever out, but it'll never touch this line. Now, you can use the unit circle to your advantage because you can see this is a 45-degree angle right here, and going down to this one is also a 45-degree angle, which gets a 45-degree angle here and a 45-degree angle to here, which kind of shows you. And then as you get more and more close to this, the line gets steeper and steeper, you can see. And then, so say you want to go off in another direction. Say you want to figure out what all these ones, like this one, or this one, so you would go to this side of the unit circle, which would be 3 pi over 4, which is right here, 3 pi over 4. Now, what does that equal? Well, we see on the graph it equals negative 1, but how does that work? It works because you have the same two numbers again, so you put them over each other, but one of them is a negative, so it would be a negative 1. You put these, and then you put 0, 0 for pi, because 0 divided by negative 1 equals 0. Now you go down to the bottom 45, which leads up to the next one, and there's two negatives on top of each other, but they're both the same exact number again, so that would just equal positive 1, which you can see right here. So this goes on repeating forever and ever, just like the sine wave. The sine wave went like this, though, and this one just squiggle, squiggle, squiggle. And now, so this is all great. You know how to do the basic graph of this one. Now, what if you want to add a number in? Now, let's start off with an easy one. Let's start off with y equals 2 tan x. Now, we're just adding this 2 in right here that I'm putting a box around. Just a simple thing. Now, when you're finding the y value, all you have to do is the previous y value of the graph that you see up here, all these values, is times it by 2, or times it by 3, or times it by 4, whatever the number is in front of the tan. So you see negative 2 right here, and you see 0 right here, you see 2 right there. Now we can add so many more columns out here that are going on forever and ever and ever, because, I will explain to you later, the range is all real numbers. Now for graphing this is a great graph example because you can see the original graph and you can see the new modified graph. So you can see how the old graph intercepted at 1 and negative 1, and this new one intercepts at negative 2 and 2. And they both intercept at 0. Now, if you were to do maybe y equals 3 tan x, then that 3 would be down there, and it would be up here. Now I'm going to try and graph this, but it's a little bit difficult with this. So let's see how well I do on this one. Okay, not bad, not bad. So you can see how it just gets narrow and narrow. It just gets more stretched out and more stretched out. So at some point, you're going to be so close to this line right here, you probably won't even tell a difference between the line and it, because there's just so many. Like, say if you go up to y equals, let's get crazy here, 100 tan x, then you're very, very close to it. Now, let's talk about the domain and range, and let's use this graph to help us out. Help visualize it for the visual learners out there. So, the domain equals all our numbers except the multiples of pi over 2. So as you can see, it never crosses this one right here. It never crosses this one, which is a multiple of 2. It's a negative multiple of 2 because pi over 2, sorry. Because it's negative pi over 2 versus pi over 2. And then you got 3 pi over 2, which is another multiple, negative 3 pi over 2, and it never crosses those right there. Never crosses those. And the range is all real numbers. Because as you can see, as I showed you right here, it'll keep going up forever and ever, but it'll never touch this dotted line right here. It will never intersect the dotted line. And go all the way down here too, and it will never intersect the dotted line right here. And that is how you graph y equals tan x, the basic function, and a variation of y equals tan x, which is y equals 2 tan x. Thank you for listening. I hope this is very helpful, entertaining, and good luck on trigonometry.